Okay, give it a couple of seconds. All right, hello everybody. Thank you for joining us for the serverless panel. Today we're going to be talking about the future of IaC, the ROI of serverless, and potentially a bonus topic. Today we're joined by some of the people that I admire the most in the industry, in the serverless space. And as our description said, 6 serverless experts with some really juicy topics. So I hope you're excited. The way that we're going to structure this is we're going to first do a round robin of intros. And so to kick that off, I'm going to toss the microphone over to Brian.
Oh, had to unmute there. Sorry. Hi, I'm Brian. I'm the co-founder of Begin.com, creator of Arc.codes. And I'm actually 18 years old, but I've been writing CloudFormation, so I look a little older.
Awesome. And after that, let's go to Thorsten.
Yeah, my name is Thorsten. I'm a cloud evangelist or cloud automation evangelist, as I call it. And I'm educating people and consulting people on using infrastructure as code and especially the CDK.
Yeah, fantastic. Emrah?
Hey, this is Emrah, and I'm working as the product manager in Serverless Inc. on Serverless Cloud. And I'm into serverless for like almost 5 years now, and I'm at Serverless Hero. I'm very excited about like where it goes with the infrastructure as code, and would like to chat about it today. Thanks for having me.
Awesome. Gary?
I'm a front-end engineer on the serverless application experience team at AWS. Previous to this, I was on AppSync, and previous to that, I was actually at Serverless Guru with Ryan. So lots of really great memories there. But yeah, I've been doing serverless for, I think about 5 years now. I'm really excited about where it's going to go.
Fantastic. Last but not least, Jeremy Daly.
Hey, I'm Jeremy Daly. I'm the GM of Serverless Cloud over at Serverless Inc. Been doing web development and application development since the late 90s and been doing AWS stuff since early 2009. And then as soon as AWS or as soon as Serverless and Lambda started hitting the scene, I pretty much dedicated my entire life to working on that. So I have a podcast, Serverless Chats, and a newsletter off by None. I'm just excited about serverless and the future of it.
Awesome. And my name is Ryan Jones. I'll be DJing DJ Jones on this one. DJJJ, I guess. I started Serverless Guru in 2018. Since then, I've been wearing many different hats and seeing serverless kind of blossom and my own journey in that too. So really excited to be here and to have all of the panelists here as well, and of course the audience. So getting into the first topic, so we're really sticking to schedule here. We're going to be jumping into the future of IaC, the future of infrastructure as code. So to kind of set the scene and overall context of it, there's a lot of different ways. As the saying goes, there's a lot of ways to skin a cat. You shouldn't be doing that. So don't skin a cat. But if you did, you could start from the back or the front, or you could do like middle out. Shout out to Silicon Valley there if you've seen that show. And on that note, let me first jump to Emrah. So Emrah, what do you think about the future of infrastructure as code?
Yeah, so like before even talking about the future of it, I remember like how I started with the like, past of it. Like I started with like clicking the buttons from the AWS console. Then I discovered something called like CloudFormation, which also made me kind of older, but I got rid of it like quickly. And with serverless framework, and after that like SAM came out and the CDK came out, I couldn't actually, to be honest, keep up with the CDK, and like I just read about it, and like it's awesome. Like there is a reason that people are just like liking it. And if you talk about the future of IaC, like all these technologies actually appealing people who are actually understanding what they are doing on clouds, especially on serverless, let's say. But like these are still includes like kind of a learning curve, which is not easy for newcomers. So that's why I also started to think that like tools that are actually targeting people who doesn't know much about serverless or who doesn't know much about cloud, develop applications and to provision applications in an easier way. But I'm not talking about no-code tools here. I'm talking about the tools that like lets you integrate with the other cloud services with the less and less effort. And also, in the meantime, I also think that like in the future we will see the increase of tools like CDK, which lets you write infrastructure code in different languages, and I think this will go in parallel. So like the cloud experts will still take advantage of the CDK type of tools and maybe Pulumi, but we will see non-experts like taking advantage of tools that doesn't actually require you to learn something new. But in a very long future, I see a decrease of usage of like the YAML based infrastructure provisioning, but I may be totally wrong.
Awesome. Yeah, fantastic. And next up to hear the future of infrastructure as code, Thorsten, what do you think?
Yeah, so also looking at the past, so I started using CloudFormation in like 2012 or something like that, so really early on, and it was a great experience to be able to write my infrastructure, to not click around and do this. And so looking in the future, I hope that more people will see the benefit of doing this. First of all, no matter which language or tool they use. So I think we can have this discussion. One, what is the right tool to do it, or have this tool wars about what is the best infrastructure as code tool. We don't need a war because it's CDK. No, and the thing is, that's one of the things. But then we're discussing in our bubble of people already using it. But the big thing is, how do we get users not using infrastructure as code to start using it? Because that's the big majority of people not using it at all. And so my thing is, which tool should I use? I don't care, but use one. That's so the main thing. Start using infrastructure as code if you don't do it yet. And then we can discuss what might be the right tool for your use case. And in the future, yeah, lowering the barrier is definitely a thing, because yeah, starting with CDK, it's great if you know what you're doing, but honestly, yeah, setting up a project, people struggle with setting up a TypeScript or a Python project. If this is the entry barrier, all other things are hard. And then you still need to know what's going on. You need to know all the infrastructure you own afterwards. So there needs to be a lot be done to simplify things. I think Terraform modules or CDK constructs or other things can help by making it reusable. So you don't reinvent the wheel and you can start with the things you want to start. But I think the future of infrastructure as code is more people using it. And that's the main thing. And then the rest will emerge.
No, fantastic. I know that that response, we're going to definitely have some time in the open floor to go back and forth. The next person I want to hand off to is Gary. So Gary, what do you think about the future of IaC?
Yeah, so I was trying to think about different categories of things. Like I think we could say infrastructure as code and code as infrastructure as two separate things to talk about. If we just talk about infrastructure as code, I think declarative deterministic templates is a good idea, is a pretty good idea. And I think I don't see that diminishing in its importance going forward. And so when I think about tools that do this, Terraform, CloudFormation, and then so you could say like, well, we're already in the future. We're using this thing, and it's going to continue to be like a foundational sort of part of infrastructure as code. And if we just focus on CloudFormation itself, we can say, I mean, we've been in the future for a long time. It's been around for a while. Like Thorsten mentioned, he started using it in 2012. You can actually look on YouTube on like reInvent. I think reInvent 2012 was that the first one? I can't remember. That was one of the first ones. They were introing CloudFormation, and it's kind of shocking how recognizable it is. Like you look at the console, it's the same. It has like events, it has resources, outputs. And it's like, oh my gosh, they really got this right a long time ago, and it's been this foundational layer for so long. And so, I think CloudFormation or tools like it are going to be, continue to be an important thing. I think when you think about serverless development, CloudFormation itself is maybe not enough. So you think about when you create Lambda functions or step functions, there's more to do than a CloudFormation template. I mean, you could inline the code, but that doesn't quite work because you have 4,000 character limit on your Lambda functions. It doesn't quite work that way, or it's not going to get you too far. So then you have to take care of zipping up your code, deploying it to an S3 bucket, and then update the Lambda config to listen to that, to point to the S3 bucket. So there's all these different things that involve SDK calls and a CloudFormation deployment. And so if only we had frameworks to help us with this. Of course, we do. So that's great. We have serverless framework. We got SAM framework, got Architect. There's other things, areas in which CloudFormation might not be the whole story. For example, like if you want fast feedback loops, maybe CloudFormation, the deployment is not fast enough. And so there's different ways in which you can accomplish a fast feedback loop. You can spin things up locally. You can drop down to the SDK level and deploy your Lambda function change that way. But so I think there's a bunch of interesting conversations around what's the best DX for serverless deployment or infrastructure as code. I think CloudFormation isn't going anywhere, or Terraform, or any of these types of tools. But I think the ways in which we use them and build on top of them are going to be interesting going forward. CDK, of course, is an interesting one. It ends up creating, CloudFormation and all the different frameworks we have. And so I think what I'm most interested in is to figure out what the DX is going to look like, because as was already mentioned, there is a bit of a learning curve, right, with all this stuff. And we want more people to be involved in serverless, but there is this huge learning curve. So we need to address that somehow with the DX that we provide in our frameworks.
Yeah, awesome. I know we're really getting into it. I've got 2 more questions once we get into the open floor. On that note, let's go over to Brian. Brian, what are your thoughts on future of IaC?
Yeah, IaC is very important. So the first thing to understand about infrastructure as code is it's a way of dealing with dependency management. And so in one way I like to try and describe it to people, because they're like, why do I need to do this extra stuff? I shouldn't have to do this stuff. And it'd be nice if you didn't have to write tests or use revision control either, but we have good reasons for those. So the reason for explicit dependencies is so that we have explicit reproduction. And so very similar to your code dependencies in a lock file, we'll put our infrastructure dependencies in some kind of a manifest format, or possibly even just imperative code. And so I don't see this practice going away, but I do agree with everyone here that the practice is still early. It's still pretty verbose. It's very complicated. There's lots of different vendors. There's tons of noise about the approaches, and that's pretty normal when it's early days. So the future's here, but it's just not evenly distributed yet. There's a large group of people that really believe this shouldn't be necessary. I think once you've started building more complex systems and you've got lots of resources like database tables and queues and events and DNS records and certificates, you're going to want to explicitly define those things and have those locked in version control so that you have a revisionable history of those things. You don't want to have a checklist where your developers are clicking around in a console to recreate their environment. That's very, very error prone. Now, how much of this can we hide and how much of it can we make implicit is an ongoing argument. Architect hides a great deal of this inside of its own manifest format that's extremely high level. It's something like an 80x improvement over CloudFormation. But could we get that to 0? That's a worthy goal, and that's a great question. I think that's one that we're all asking ourselves right now. And future's here, and it's going to be IaC. I just don't know which one and how it's going to shake out.
Awesome. Okay. Well, handing over to Jeremy. Jeremy, thoughts on future of IaC?
Yeah, no, I think that I think the need for creating some sort of manifest that will create deterministic deployments so that you're getting the same thing every single time is 100% where we need to be. My biggest problem with infrastructure as code right now, especially with CloudFormation and pretty much most of the tools that are used to create CloudFormation, that create it behind the scenes, whether it's serverless framework or even the CDK or something like Amplify, is that, again, you're still generating and working with this idea of primitives. And primitives, we just had Werner Vogels on the podcast, which was awesome, and that episode's coming out soon, so make sure you listen to that. But, he loves primitives. He loves this idea of giving people a lot of control over what they can do. But the problem with primitives is not the primitive itself, it's the wiring between the primitive or the primitives. And this is something that is constantly changing and constantly evolving, right? So it starts off that you use a dead letter queue, and then suddenly it's better to use Lambda destinations, and then something else changes. Then all of a sudden now you have rolling updates and all these other things that you can now do, which means you have to change the configuration of your IaC in order to accommodate that, right? So every time you write anything in IaC, whether it's declarative or it's in the CDK or something like that, that code is not obsolete yet, but it will be, right? And there's this term that's really interesting in real estate called functional obsolescence. And that's basically when you build something a certain way because that's the standard of the time. And then the next thing you know, they're like, well, you don't walk through another room to get to another room. That's functionally obsolescent. And that's what we are essentially doing when we are writing infrastructure as code, is we are writing code that is going to be out of date very, very soon and not support the new features and the new capabilities. And so every time we drop down to that primitive level and we write that explicitly to say, oh, well, I'm going to use this dead letter queue, or I'm going to use this particular event mapping or whatever, when that changes, we then have to go back and rewrite that code and potentially change the way that we deploy our infrastructure and all other types of things that may be affected by that. So my problem with infrastructure as code from the primitive standpoint is right now we're essentially just writing control plane commands to AWS or whoever we're writing that for, and that's inherently going to be a problem. That's a lot of extra code or liability that we now have to maintain. And so I think where I would like to see the future of IaC, and again, Architect I think has taken a really great step towards this because you're reducing primitives to use cases, not quite all the way yet, but we're getting there. And the same thing we tried to do with Serverless Cloud is to essentially say we want to address use cases, not, it doesn't matter whether you set up an API gateway to a Lambda function or you set up an ALB that somehow maps to a Fargate container behind the scenes. That doesn't matter as much as expressing I want to create an endpoint that's accessible via HTTP. And that's where we have to get to. And I do like about the CDK, although I get concerned with the CDK that people can dynamically change things on every deploy, so you don't get that quite deterministic thing. But I love the idea of constructs because that's what you're saying. You're saying, I want to deploy a webhook, right? How that gets deployed doesn't really matter. Just give me a construct that says webhook, and maybe today it deploys with a Lambda and a API gateway. Maybe tomorrow it's routed through CloudFront and to a function URL or something like that. But the point is that the more we drop down, the more low level we get, the more liability we add, and that just adds a ton of tech debt that you're going to have to be dealing with in the future. So my hope for the future of IaC is it focuses on use cases, and that the use case that actually gets deployed may be dependent on a number of different things, but you're not going to be stuck in the weeds and saying flip this switch, flip this switch, flip this switch. Okay, yeah, fantastic. Well, I think I want to ask a follow-up question to Jeremy's because I think it's fresh. What does the risk profile look like when we have a third party that maybe isn't AWS that is acting as that abstraction layer over those primitives? Is that does that then run a risk of having to migrate away in the future? Are they able to keep up with the changes? Is that the way that it should kind of be structured? What are your thoughts? Yeah, no, I think that's a really good question. And I think that there's a lot of security in any application or any framework that essentially compiles down to CloudFormation, right? That kind of compiles down to that native format that AWS is going to deal with. And AWS is going to continue to add all kinds of features, and they have the the drift detection and rollback and all these other things that are really nice features of CloudFormation. The problem is that CloudFormation is horribly slow, and it's not the type of thing for rapid feedback and stuff like that. So again, you're going to have to find a better way to iterate on code that's running in the cloud in order for you to test things that are fully integrated into the cloud. And so if you look at what SAM is doing with SAM Accelerate, they have this process where they essentially redeploy a Lambda function for you. And then it redeploys that Lambda function, has access to everything in the cloud, and everything is mapped correctly for you. And it's a really good feedback loop. We're doing something very similar in Serverless Cloud, where we're syncing, any file changes you make. And if there's a change that requires some infrastructure, we'll deploy that infrastructure, but we can do that very, very quickly. There's something else to be said about the local feedback loop, right? We just added full stack capabilities. We have to run your full stack dev server locally. Otherwise, it'll take way too long to make a change to react and redeploy it and do that, rebuild it and all that kind of stuff, right? So again, like what Architect is doing with the way that they're mocking those that local experience, that's really great because it gives you this really great feedback loop. Even local stack has some, there's some benefits to potentially doing that. But I think the future is going to be, we have to get things into the cloud as quickly as possible. We have to segment them into the cloud as quickly as possible. I posted the other day, replying to Brian's tweet, AWS accounts have to be disposable, right? AWS account isn't some, stone structure that we build. I mean, we should be able to tear that down and spin those up, as easily as DynamoDB tables. So I do think, going back to your original question, that there is a risk by choosing somebody who is going to just be interacting with APIs and potentially, making changes to the infrastructure. But if you're relying on CloudFormation to be the tool that gets you from local into some sort of, cloud high fidelity type, dev account or something that's close to production like, that is just way too long of a feedback loop, right? And even AWS knows they can't do that. And so I think that other providers are going to need to start going down that path. Now, there may be an exit, like what you can do with Amplify, where you can basically eject or graduate or whatever they call it, and just get the CloudFormation template, and at least you can rebuild it and you have that security. But I think that, from a developer experience standpoint, CloudFormation is not going to be the standard, or can't be the standard for iteration and for development. It may be a standard for now, at least as that backup, but certainly not as part of the developer experience.
Awesome. And on that, I want to open it up to the rest of the panelists as well. Thoughts on that question? Otherwise, I do have a developer experience question next.
Well, I think a CloudFormation, you can almost reframe it as the save button, right? Like you have this idea of, I'm changing my code. I want to get a feedback loop in a dev account. So I'm going to do these SDK calls or whatever. But then when I want to actually commit it to code, I do CloudFormation, and it maybe takes a little bit longer, but it's the save button. You could reframe it that way.
It's definitely growing into a compile target. I think that's a safe statement. I think if I said that 3 years ago, people would have shit on me. But at this point, like we've now kind of generally seen a lot of solutions have grown on top of it, and Jeremy's right. It's very complicated, and it's a heavy lift for someone coming from an imperative programming language. Which is why CDK is such an important learning tool for folks to grow familiar with these constructs and ideas and concepts. They can write imperative code and then see the declarative other side of the story, and I think all these things reinforce each other and build up on each other anyways. But it's definitely it's pretty rough. If you want a single line, like a single HTTP handler, just one Lambda, one Lambda function talking through API gateway, that's like 350 lines of CloudFormation that nobody's going to write by hand. So most apps have more than one route. They usually have a few database tables and a couple queues too. So like we do need better solutions at a higher level for folks to get onboarded, but also just so they can maintain these things.
Absolutely. And I want to ask a question to Gary on a similar topic. You mentioned the learning curve, and that was mentioned as well a little bit by Jeremy Daly as well, and also developer experience. So from your perspective, when you think about those things, developer experience and the learning curve to understand CloudFormation and so on, what's the path forward? I guess, like, what do you think about that? What should a developer experience look like for IaC? And what ways could we potentially help the learning curve process?
Yeah, it's an interesting question, because on one hand, you could say CloudFormation does this job really, really well, but working with it is difficult. And we could talk about DX, but developer experience. I want to talk about like HX, the human experience. Like as a human being coming to this weird world of cloud and infrastructure as code, is it ergonomic for us? Does it work? And I think ergonomics is a good sort of term to think about this stuff. Whenever you teach, like I've taught people, you try to introduce people to serverless because I'm enthusiastic about it, right? So you talk about AWS, you talk about CloudFormation, and the reaction is interesting. People who are not used to it, it's like they're kind of, I don't know what word to use. They're overwhelmed, and they don't know if this is something they can do sometimes. And so I think we need to, as good as technically as CloudFormation is at solving the problem that it's solving, I think if you look at it from the other angle, we need to think of the ergonomics of the cloud and need to think about how can we enable people to develop on this platform. And yeah, I think that's what really the task is for us going forward.
I also think if you think about CloudFormation too, like CloudFormation is great for what it does, but it's not, even that in and of itself is not the end all of, especially for serverless applications where you are, and somebody mentioned it, you have to upload zip files or containers into ECR or into S3. Maybe you have data that needs to be populated when you spin up a new instance. You need some target data or test data. Maybe you need additional parameters. Maybe you need environment information. There's all kinds of things that you might need to do. CloudFormation doesn't do that, right? CloudFormation will just say, okay, here's where I'm getting the code from, or here's where I'm getting the parameters from. It doesn't run, you can add in custom modules and things like that to run scripts, but now we're getting really complicated, right? So I think that's where the frameworks have really helped, whether it be serverless framework or even SAM, that has that extra step of saying like, oh, I'll also package your code for you and I'll do that. So, even just looking at CloudFormation in general, it's not, you can't just say raw CloudFormation, because then there's a bunch of other steps that you have to do in order to just run that.
Yeah, that's exactly what I really like about the CDK. So because it also supports exactly this. So you can write your Lambda function, target your TS file or whatever language you want to do, and it also does the bundling, uploading to S3, building Docker containers, uploading to ECR, and then creating a CloudFormation template that contains the correct path to this bucket or repository. So it does not only CloudFormation, but the things around. And that's a vital part of the DX for serverless. Because, yeah, it's good to deploy a Lambda function, but where does this zip file come from? And this is what CDK does for you.
Yeah, it's a big dependency management step too. So at that moment of deploy, if you have a package JSON file in your function code, CloudFormation doesn't care. So somebody's got to run npm install. Likely somebody's going to have to run a bundle step, unfortunately, if you're using things that require that. If you're writing like Python or something, you wouldn't do that. But if you're writing JavaScript, people tend to. And those steps are what creates a plausible determinism. If we don't have something, our code dependencies in a package JSON file, then we have chaos. Right? And even if we have our dependencies in a package JSON, it's still sometimes chaos, if we're being honest with ourselves. So there's a ways to go for this. And I actually feel these concepts are extremely linked. And I don't know if we've got there as an industry yet. And CDK definitely papers over some of that, which I find fascinating, because people start thinking of their code and their infrastructure as the same thing, which is maybe healthy.
Yeah, and to kind of play off of this, I wanted to toss it over to Emrah to hear your thoughts. When it comes to, we have the abstraction layer over the primitive with like SAM or with serverless framework, CDK. It makes it easier to do stuff without having to do the zip file process. It's being handled by the framework. However, then we get into, let's say my node modules is gigantic, and then that's kind of like still the Wild West, right? Like to some level, everybody has to go through the process of then learning that like you need to reduce the number of third-party dependencies to then make sure that the cold starts are like lower. And what are your thoughts on that? Is there like a way that we can address that for the user before they hit it? Is that possible?
Yeah, like it is, there are like many ways of reducing this, like using the layers and extensions and everything too. And like you can still define them as infrastructure as code, and with CDK, like most peacefully, I can say. So like, and in this way, you can actually make your applications like more ready for bundling for building and for serving to the customers, and in this way you can actually build the applications. And I really like the approach about the CDK, which tells about like I can still build use case based applications with CDK. I can create boilerplates both for the application and also for the infrastructure. Let's say that I'd like to build, an application that does like an API and talks with like several tables. I can do it with CDK, and I can bundle them all together. I can use the layers if required to decrease the size of it, and I can still do this. Or I can do this like the already designed frameworks, designed tools like Serverless Cloud for such things, that I can build an API just by writing the code that does the business logic, and it creates the most suitable infrastructure for you, and you will get this like the success of serving to your customers, while instead of just like dealing with the dependencies and like trying to reduce the size. So if we can to sum up, if we can think more like an use case based rather than just like achieving the infrastructure as code, I think it will be easier to come up with solutions that are lean and that are working in several platforms, like the production, like as if it is working in your local.
Yeah, no, awesome. Thank you for kind of jumping into that there. And I guess like I have one more question before we may switch to a different topic. Of course, I'll give y'all a chance to ask back and forth as well. What are y'all's thoughts on the percentage of people that are in the console versus using raw cloud formation versus using compiled target, which is Brian's language, to cloud formation with one of those abstractions like SAM, CDK, et cetera, and then to the GUI, or maybe like less GUI, but like serverless cloud, or I think Pulumi does that as like something like that. Maybe Stackery prior to the acquisition. What type of percentages would you say the industry is at? Is it the majority in SAM, CDK, serverless framework, or in raw cloud formation, or in console? Anybody want to take a shot at it? Of course, you won't be held accountable.
I think most people are using Architect today, actually. That would be my assumption. It's something called Brandolini's Law. I'll enjoy the rest of the show listening to you guys say how I'm lying now. So Architect is definitely not the thing most people use, for the record.
But you know what though? But like with Architect and with any of the other, there's a whole bunch of frameworks out there. I mean, and not just for like JavaScript either. There was like what was called like Jets or something like that for Ruby, and there was all these other. And then there's Breath for PHP that Matthew Napoli did. And then there's a whole bunch of them, right? So there's a number of different frameworks that try to get you, either shoehorn you into a Lambda function, and whether that's a giant monolithic Lambda function or it does some splitting and things like that. There's all kinds of things that do that. But I think that if you look back, and I don't just say this because I work here now, but serverless framework, when that first came out, that invented some of the way that we think about building serverless applications. Just this idea of sort of simplifying everything routing to a serverless function. Now, clearly it's gotten much bigger than that now, but the serverless framework in the latest Datadog survey was like 90% of users were using the serverless framework to do their deployments. And of course, again, serverless framework is, I wouldn't say it's high level, right? It still gets very low level. There's a lot of configuration options you have to do in there. So it's you got to learn it, right? But I would think that would just be the percentage of people who are deploying serverless applications, because deploying a serverless application through the dashboard or through the console is, I think it's almost impossible, right? I mean, like you can't really do it unless you only write like 10 lines of JavaScript or something like that, right?
It's impossible.
Yeah, exactly. So,
point, yeah.
So from a serverless standpoint, it makes sense. But I think from just a general standpoint, I would be surprised if it's 90% of people are in the console all the time clicking around. And I think that it's partially that, because as bad as the console is in certain places, it does allow you to do certain things, right? And I remember when I was still deploying servers and using OpsWorks or whatever that service was that they had there, right? And I remember doing most of my stuff in the console. So even though I wrote the scripts for it that you would load in and pull in through Git, most of what you would do in terms of deploying and checking things and monitoring was all through the console. And I think that there are still people, and you can see this evidenced by the fact that AWS continues to invest in things like, the DynamoDB console, tool. It's almost useless, right? I mean, unless you're scanning, unless you know what you're looking for, right? What are you going to keep scanning through millions of records? I mean, it doesn't even make any sense. So like having the ability to run certain queries and things like that, but again, they're not mapped to your entities if you're doing some sort of data access layer or whatever. So it's just sort of impossible to use. It's not a very good tool. It's not very useful, but it seems as though either people just have nothing to do and they have to keep adding features to these things, or they're seeing a usage and people requesting this type of functionality. So I think that and the new testing, the sharing test events in Lambda, like how often do you use the Lambda console? Like honestly, it's almost never. Like the only time I go in there is sometimes to check to get to the right CloudFormation logs if I haven't wired it up to some observability tool yet. So I think that
I did use that the other day.
Did you? Did it work?
Actually, it worked. I was like, oh,
interesting.
Cool, I guess I had to replay an event, and I was like, took it over to the console and I popped it in there.
There you go. So I do think that there are useful, right? There are cases where you need that console, but the question is that are they designing the console to be the constant, to be the tool that they expect people to use? I mean, even a lot of the blog posts that you see written, they don't even mention CloudFormation. They just basically say, here's how you do it in the console, and then sometimes they give you the CLI, which again is sometimes helpful for structure and some of that stuff, but it's not CloudFormation. I mean, that should be really the first place that they go, or SAM or CDK or something. But yeah, I find it. I think the vast majority are using console, and then when you get into specific niches, especially with serverless, everybody's using some sort of framework because it just makes sense. Or most people are using some sort of framework. But yeah, I would think it's a scary number of people who are not even thinking about IaC at this point.
Yeah, and even if they do, they still use the console. So what I'm seeing in my consulting work is that people are using CloudFormation, but deploying it only using the console. So going to the CloudFormation console, updating the stack, creating the stack, and doing all these things. And one of the reasons is, especially in big companies, they have no idea how to run any CLI command on their machine because they don't have credentials on their machine. They have proxies, they have a Windows, and they have no idea how the CLI should run there. So they have these stripped down development, I wouldn't call them development, workstations, where everything that works is a browser and Notepad. So they use Notepad to copy paste CloudFormation and then upload it using the update stack functionality of the CloudFormation UI. So that's the reality. Yeah, but it's a reality in a lot of customers I see. And I would love to have more of them on other things, but that's where the reality is.
It's shocking how far ahead Amazon was on this, right? Like 2011 is when CloudFormation launched. And I think the biggest indicator of how far we have to go as an industry is to just take a quick glance at what the other clouds support for infrastructure as code. And they can shortcut you. It's called Terraform. So they don't really have much else in the way of native CloudFormation capabilities, which is a nice way of saying they're abdicating back off retry and failure to a third party, and all the consequences that come with that. If you look at a whole bunch of the like sort of next gen clouds like Vercels and Netlify's, this isn't even a concept on the roadmap for them. So we have a long ways to go as an industry to get to the place where we have deterministic deploys as a default. And the vendors are a part of that problem because they're not aware of it. And you know, they ask the customers, and the customers will probably tell them, "I want a faster console." Right? Like, I wish I could
faster horses.
I need to click that button quicker for deploy.
Wow, it's so insightful. Oh my gosh, I'm so happy to ask this question because, you know, something about serverless guru is we like almost entirely work with serverless. So I'm somewhat in a bubble sometimes around like my understanding of this. So hopefully that's really useful to the audience to hear some perspectives about like what things are still going on in the industry and kind of the idea of like where we're trying to push it. So I think this overall conversation is like we're years ahead, and in some cases we're many years ahead of the years ahead, I guess, and in terms of solutions and thinking about these problems. So fantastic. On that note, let's go ahead and transition to our second topic for today, which is the ROI of going serverless. So, what does it mean to go serverless? What is the process of that? How do companies address this kind of change? Is it as easy as just switching? Is there a whole bunch of org changes? Is there team changes? Like all those things. So to kick this conversation off, I want to hand it over to Brian. What are your thoughts on the ROI of going serverless?
So the return on your investment is probably developer velocity at the end of the day. But it's also 100% utilization, which is a very opaque term. And so when you're deploying on premises or to the cloud and you're load balancing a monolith, you want to deploy that to at least 3 availability zones so that you have some degree of fault tolerance. If there's a problem, you want to be available, which is a nice way of saying you leave servers running that aren't meeting any demand. And that's inefficient. You have overused capacity just in case there's a spiky event. I worked at Adobe for a little while in Creative Cloud, and we were over provisioning for billions and millions of dollars worth of servers. And we did that because you don't want to be the guy that brought down Creative Cloud. And you want to be available in case any big traffic spikes come. Serverless flips that on its head. Now we're at 100% utilization. You only pay for what you use and you pay by the millisecond. And if you go all in with the cloud, this is really nice because your costs are going to drop very low. Economics of just pure spend on compute. Now, that's nice for your wallet, but the developers are going to be happier too. They're going to gain a lot of determinism, and through that determinism, they're going to get a lot of reproducibility, which is a nice way of saying when they have a bug, they're going to be able to fix it really quickly. Right now, if I have a bug in my monolith and it's deployed to a cluster of 50 servers, well, where's the bug? I don't know. I'm going to have to grep around in that giant monolith. If I have a bug in my post-contact form Lambda function and it's erroring more than normal, I know exactly where that code is, and I know exactly how to fix it, how to reproduce it locally, and then deploy it. That's really nice because that means I get to go home at 5. And when I'm on my weekend gardening and doing my stuff with my family, I'm not sitting there thinking, geez, I hope that cluster is still running. I don't want it running. It should only run when someone requests my code. And so 100% utilization is really nice for your wallet, but it's also nice for your developers because they know what they're building is going to keep running when they're not hanging out at work.
Fantastic. And handing it over to Emrah. What are your thoughts on the ROI of going serverless?
Yeah, no, while deciding for going serverless, so we always see greenfield projects that hey, we have this new project, let's make it in serverless, so it will be great to it will be easier, maybe more cost efficient. So it is easier to say, it is easier to decide for greenfield projects, and people can understand the ROI of these type of projects, but Brian already made great points about it. But I also want to mention about the brownfield or a migration projects. So these are the projects that were the most how can I say opposition coming from inside of the company, or maybe sometimes the outside of the company. Why do you want to even just migrate an application that's running peacefully to serverless? You shouldn't do this. So, and there might be very cases that is actually true, but for such projects, such products, so it's still worth migrating to serverless, and very much worth because as Brian says, that it gives you the ability to resolve the issues a lot faster, and it also gives you use a more modern technologies that helps you, that actually should motivate your engineers inside to use this, because no one wants to deal with the technologies of the 15 years before, and this actually kinds of create a job motivation for anyone, for transferring this information to themselves, and in such cases you are creating a more resilient, ultimately scalable application, and this is actually creating less cost, happier developers, and like at the end of the day, happier customers, because you have more resilient applications, and that totally pays the the effort that you are putting on the table for migrating the applications as well.
Awesome. And I'm going to hand it over to Jeremy. What do you think about the ROI of going serverless?
Well, I mean, one thing that we probably don't like to talk about, but we really do need to talk about, is that serverless is incredibly expensive in terms of the actual cost of running something serverlessly. So if you look at SQS queues, if you get a couple hundred Lambda functions pulling SQS queues, that gets pricey. If you have, CloudFront invalidations, that gets pricey. Data transfer is, just a general problem, that gets pricey. But there are, CloudWatch metrics. 30 cents for a metric for every dimension. That adds up very, very quickly if you're trying to track things across a number of different metrics. So things get expensive when you are running serverless infrastructure. But as Brian said, it's this idea of 100% utilization. So you really have to look at it in terms of saying, well, if I invest in putting all this time and energy into building this serverless application, and I'm going to rely on EventBridge, and I'm going to rely on SQS and Lambda functions and API gateway, then I'm paying, if I'm using regular REST API gateway, I'm paying $3.50 for every million API requests. I've got the Lambda functions running in the background. Maybe I need a little bit of extra temp space. Well, guess what? Now they're going to charge you a little more if you want to run temp space. Like maybe you do have some requirements for provision concurrency, not so much to keep things warm, but because you just need to make sure that you can scale a fleet maybe when you have a larger expected traffic bump coming in. So these things get very, very expensive. And if you just look at it next to, I can run 3 T2 micros, if you look at it next to that, then yeah, it's insanely expensive. But you have to look at it not only from, again, I think Brian, you mentioned this, the idea of the developer productivity, the amount of time that you're going to save from the developers, but also just, again, Emrah mentioned the developer happiness metric, which I think is probably the highest metric we need right now, given the fact that pretty much any developer can go anywhere they want to right now and probably make twice as much as they're making right now. So I mean, it is a developer's market, and keeping people happy and sane, I think, is hugely important. And I know for me, and again, I think this is a universal rule. If it takes you, if it used to take you 8 hours to do something, and you could do it, and now you can do it in 4 hours, you're going to find more things to do in that other 4 hours, right? So you're just going to do more, right? So you might not, it's not like you need less people that you can say like, we're going to fire half of our developers because we can do everything in half the time now, or we can do everything in a quarter of the time. We're going to be able to do more, right? And not only that, like maybe it reduces our dev or our ops, right? So our DevOps drops down a little bit. So now we can do more interesting things with DevOps. We can add more automation. We can, again, make developers more happy. So I think that's the trade-off that you have to think about, is to say, there's the huge return on investment. I don't know if it's going to be like, cut the number of developers, because we don't want to do that, right? But being able to build more or build more better. And as I was saying, sort of the way that I think about it is, when I'm building serverless applications, I probably spend 75 to 80% of my time thinking about it, and then 25% of the time actually writing code or implementing it. And part of the reason for that is because of the complexity of serverless applications and all the things that have to be done, and what are the boxes that need to be ticked and so forth. So again, as we get more advanced with IaC, as we move more towards use cases and things like that, I think the ROI eventually is going to absolutely skyrocket, because then it's going to be, I just need to build a webhook, and you type 2 lines of code, whatever it is you want to process, and then that's deployed, and it moves through some sort of deployment pipeline or whatever it is, and it's just up there, it's running, you don't have to worry about it. And even if it costs a little bit more to run it, the ability to do that and not have to worry about, again, getting up on the weekend or interrupting gardening on the weekends or whatever, that is a huge benefit. Ben Kehoe mentions this all the time. Christmas morning, hey, no alarms went off, right? Even though tons of people are opening their Roombas. I mean, that's a pretty powerful reason. That's a pretty good return on investment, even if it's not totally in the form of, cash or cash savings.
Fantastic. I also, when you said you said a part around, it's not going to eliminate jobs, I just wanted to give like a funny funny story. Funny for probably everyone in the audience, less funny for me. I did one of my first big talks was at New Relic's office in downtown Portland, Oregon, and it was the DevOps day, not DevOps day, but DevOps event. And so I got introduced, and they're like, Ryan's going to be telling us about serverless and not about how it's going to kill all of our jobs. And I was like, oh my gosh. And so, yeah, kind of just like a funny moment where it was like, no, it's not going to like end your job. It just basically it's taking the domain knowledge and all the skills you have currently, and then just making you more efficient and do less like mundane repeated tasks and spend more times on things that actually are like really enjoyable. And yeah. So on that topic, let me go ahead and switch it over to Thorsten. Thorsten, what do you think about the ROI of going serverless?
Yes, so I see a lot of customers thinking about serverless for the first time with very low loads. So it's not about the big pricey things, but so what's the cheapest option to run a server or run an API endpoint that's not serverless? It's a load balancer. It's at least 2 containers or servers or whatever. So you start with about $30 or $40. It's not much, but with serverless, you can do it for the free tier or $1. And if you multiply this by a lot, like having microservices and having 100 services in this category, and you need them once a day, then that's where customers start thinking about serverless to get their cost down to 0 during testing. Every developer could have their own development environment. I don't care if I have 100 Lambda functions running around. They don't do anything. So do it. Try getting every developer their own environment using Fargate or using servers. Nobody's going to pay for this. And so that's
Beanstalk.
Yeah, or Beanstalk. So that's where you get this return of investment for being cheaper on all your development environments you do not use all the time or at all. So that's one of the big things, and it's back to developer happiness and speed. So if I think about, so having one example, deploying new code. If you deploy new code, despite CloudFormation being slow, if you do CDK deploy, it synthesizes your Lambda function, it uploads it to S3. If you use CDK Watch or Hotswap, it will bypass CloudFormation and just do a function code update. But the next request coming in will hit your new code. Try doing this with containers or VMs. It's packaging, uploading somewhere. Yeah, so it takes a lot longer. So in the section before, we were discussing like it's taking minutes or seconds if it's before it's live in CloudFormation. Yes, but if you deploy to a server or a container, it takes minutes or hours. So, and that's the speed of getting my change into some environment where I can test it. Basically, with CDK Watch, it's hitting save, waiting for 2 seconds, the next request hits your new code. And that's where speed comes in and feedback comes in. And that's, I can think of something, build it, try it out, and it's done. Instead of deploying it, forgetting about it, grabbing coffee, doing something else, and then coming back, oh yeah, there was something going on. So that's where the investment or the return of investment comes in, that features hit the road faster. So I get my features done because I don't wait for them and forget about them during their deploy.
Thorsten really loves that CDK thing. I have a feeling like he wrote a book about it or something.
Maybe I wrote a book about it.
Oh my gosh. All right, so going to the next person. Gary, what are your thoughts on ROI of going serverless?
I think for me, the biggest one would be developer velocity, like has been mentioned before. And, I think just in my own experience and how it's affected me, when I started in web development, the teams I was a part of, it was usually like front-end people, back-end people, and then ops. And there's very strong silos, big walls between those groups of people. And you need like a manager to mediate between them. There just was no sort of awareness of what it was like to be a part of those other groups. And often when you're developing features, there'd be miscommunication between those groups. And it was rough. But when I started doing serverless development, and you immediately become a full stack. At least that's been my experience, because you have to think about everything, right? You have to think about your infrastructure first, and the impact it's had on me and my own development or velocity is, as a front end developer, back end developer, or whatever, I tend to think in terms of resources. So if I'm making a front end application, I'm thinking about S3, I'm thinking about CloudWatch. How am I going to visualize or monitor this thing? And that's just the level that I think at. And that's been, for me, that's been really good for my velocity. It's been good for my teammates' velocities as well. I've been in companies where we just hire just developers. We don't specify front end, back end, or ops. It's just you're a serverless developer who works with a full stack, and that's all there is to it. So I think that's one outcome of being what serverless does for a team, is it can potentially change the way your team is structured, and it could potentially get rid of those silos. But I'm interested to know, Jeremy, what your thoughts are on this, because, when I think about code as infrastructure, where it's like you define your business logic and infrastructure is derived out of that. You don't really think about the underlying infrastructure. That's a different angle. And I'm wondering, how do you see serverless cloud and how that changes the way people think about serverless infrastructure, or the way that teams are structured and so on?
Yeah, I mean, I think what we tried to do is we call it infrastructure from code, as opposed to infrastructure as code. But essentially, we defined an SDK that you have access to. So you say API.get, just like you would in Express or whatever. And then we can process that when we load that file, and we can look at it and say, okay, you want an API and you want a get route. And so we can generate whatever infrastructure you need in order to support that. And the reason why we're doing that, again, whether it's for schedules or events or whatever, is because it doesn't matter if we deploy to a Lambda function or to a Fargate container or to a VM somewhere or to somebody's Raspberry Pi in their garage. It really doesn't matter. It shouldn't matter so much to you. I mean, I'd care about the Raspberry Pi thing, but essentially we can deploy whatever infrastructure makes sense for your service to run how it needs to run, and it can be optimized over time. So we could start by saying, look, it makes a lot of sense just to spin up that Lambda function with an API gateway, because as Thorsten said, we don't want to pay for it in development or whatever. But if that starts getting hit over and over and over and over again, we're like, well, you know what? It might make sense to actually spin this up on Kubernetes with EKS and have that running in the background and just route those requests to that instead, because it's a high velocity or a high throughput container or whatever it is. So that's what we're trying to do, is basically abstract away the idea of the primitives. Same thing with events. Like with events right now, we have an eventing system that runs on SQS and DynamoDB. Part of the reason why we use those and not EventBridge is because of some of the delaying techniques we have and some of the other things we have where you can look up stuff and whatever. But that doesn't mean that we can't change it tomorrow to EventBridge to support more things. You never have to change your code. You just said event.publish or event.on, right? And it's able to read that stuff. So we look at this as maybe we went a little too extreme, right? Where we went beyond the use case thing and went straight to just write your business logic and let us interpret it. But we're pretty, it's pretty solid in terms of how it does it. And I know that, again, I'm huge on deterministic deployments as well. Like whatever you write, it should be the same thing every single time. And so that's, and this does this as well, right? So it's not like you just, are writing any script you want to, and then it magically uses AI and whatever to figure out what it is that you're trying to do. You're very explicit. You're saying, I want to publish an event. I want to listen to an event. I want to write something to the data store. I want to, run an event, or I want to run a, HTTP endpoint on this post or get or whatever it is. So you're very explicit about that. And as long as those things are explicit, we generate a manifest file technically. So we know exactly what you need based off of when we read that in. So we'll add things in the future. We'll do drift protection and some of those other things. But I think it's a pretty solid way to kind of address it, and not have to let people focus on saying, I'm writing an API handler, and then I have to go define that as infrastructure as code somewhere, and then I have to do another step where I have to go ahead and deploy that, make sure everything's zipped and all the code matches up and all my builds are mapped to things, and I got to worry about maybe I got to use some sort of, I can't even think of the right term for it, but I've got to make sure that I can map everything. I'm using sort of cloud mapping or whatever. Like it's crazy to have to do all those things. So if I can just say, I want an API, I want to deploy it, and knowing that it's not being deployed to Heroku in some Linux box or whatever that's running somewhere that isn't in multiple regions and all that kind of stuff. We can do all of that just by having this very, very simple syntax, this simple SDK that expresses exactly what you want to do, and then with all of the details kind of managed behind you. And it is a bit of a black box, and we've had that complaint. They're like, well, how do I add an SQSQ? And you're like, well, I mean, you don't, because we don't supply you with that primitive. But here's how you can do what you want to do with the services that we provide to you.
Yeah, I think that's interesting because it's like there's two philosophies. It's like, do you make the underlying resources clear or do you blur it? And I don't know that there's right or wrong. I think it's just there's different reasons why you would want one or the other.
Right.
I think that's it. I think it's a use case and trade-offs and personal tastes and all those things. This did kick off into the ROI thing that I wanted to throw out there before we moved on. That's security.
Yes.
So I don't know why I always forget this one. So security and compliance, pretty big deal. Probably want to lock your stuff down. Infrastructure as code is a really great way to do that. And you can get very, very explicit. You can say this user can only access this row and these attributes in this Dynamo table if you want to be that least privilege about things. So I just wanted to huck that one over the fence into the ether that, by the way, it's also secure.
Yeah, well, and you know what? The other thing that's important about that too, Brian, is the fact that when you're using something declarative, and this is where I really like the idea of sort of that a very declarative syntax, some sort of DSL that really shows you exactly what's happening, and there's not a lot of interpretation. You don't have for loops in there and some other things that are happening in the CDK. Is that can go through a code review process, right? So you can review that and say, okay, wait, hold on a second, we don't want to do this, or we don't want to have a database that gets in there that doesn't have a good retain policy or whatever that is. You can do that at that level. You can still do it with the CDK. It's just, again, I feel like the CDK is another bit of an abstraction. And again, not because I really like what the CDK does, and I just have a couple of small concerns about things like that. But I think that if you take code through a review process, now you're reviewing your infrastructure before that even gets to that next step. And if you have a good process for that, then again, that not only adds security and compliance and all those other things, but does give you that extra set of eyes, that you can look at it before it gets, potentially does some damage to your live infrastructure.
Can be even automated.
Yes.
There's no way this app is allowed to access this stuff or can only access these other stuff. And that's actually quite nice. And we've been using Deno lately a bunch, and it's got some nice security aspects to it, but I don't need any of those things because IAM is my security layer. Like Deno, you can tell it to not read the file system. What do I care if it reads the file system of temp inside of a Lambda function and it's about to go away? Go for it. Have fun.
That's exactly another ROI factor of going serverless. It's not only about infrastructure as code for security, but it's also serverless for security. Yeah, building code is one thing, but then run it on EC2, run it on containers. You need to think of, where does this container come from? Is it patched? Is all the antivirus machine software setup done? Is there any proxies? Or you have, jump through a lot of hoops to do a compliant EC2 setup. If you have some regulator in-house and everything you have is serverless, is here's Artifact. Look at what Amazon is doing. I don't care. It's compliant. So and that saves money too, because it saves money to build these things or to not build these things, and it saves money by you won't make the front page with any unexpected things.
I mean, in the isolation model in and of itself too is huge. I mean, I remember building a startup back in 2010, I think it was. First thing I was building on AWS, and we had an idea of app servers, and then we had database servers, and we had image servers, and we basically had to create all these different clusters. Like we were building microservices back then, probably before we even knew we were doing that. But essentially dedicated servers that did a certain type of job. And of course, with our app servers, though, everything ran on the app server. So the app had full access to the database. You could delete rows, you could add rows, you could update rows or whatever. But with serverless, it's really interesting because if you have image processing lambdas, well, you can spin up 10,000 of those or one of those, right? And that can scale independently, and that has no access to the database or only has the ability to post information to one particular table in the database. And then you have other ones that can do stuff. So the services that are more destructive, right? Maybe you can put more time and energy into those and make sure that you're doing that extra layer of protection there. Whereas the other ones, you just say, well, it really can't do anything destructive. So we still want it to be secure, but at the same time, that risk, that bulkhead, that now the blast radius is so much smaller because you've really minimized what it does. And again, and then you don't have to scale hundreds of servers in order to do all these different things. Instead, you can just run independent Lambda functions that do it independently.
Yeah, and I wanted to add as well. I helped to work as an architect as well as had different people from Serverless Guru as well, of course. And we were helping on an enterprise PCI project. And what was so interesting about this, because the entire thing that we were building was serverless.
It was interesting, really? No, just kidding.
It was stressful. I'll say that. It's super stressful. The interesting part came later, of course, when you look back and you're like, oh, we made it over the hill. Now we can celebrate a little bit. But when they started handing us, questionnaires with 500 questions, of course, that's very not fun. The interesting part was none of them were relevant really. The serverless takes care of so many things for this specific PCI project. It was the first time the actual senior PCI consultant was seeing just the power of serverless in terms of just not having as many boundaries. We weren't managing the load balancers. We didn't have physical servers that we were having to SSH into. All those were requirements that were in that document, and they weren't relevant to what we were doing. And as Brian was saying, IAM was kind of the holy grail there. And then we just basically separated by environment. We had the CloudTrail flowing to an audit account, and then the entire infrastructure was API gateways and Lambdas and SQS and so on. So that was a super cool project to see. I don't know how much how widely it is talked about, that at least in terms of if you're doing something like PCI related, serverless can really jumpstart, especially for a large company where they then have to go through a gigantic PCI audit. And that can require, I think we had a team of 15 people or something crazy like that were all thinking about this. We ended up doing a lot of the development just because it was, we didn't need people to spin up the virtual machines to then make that protective. We were just writing the application code and making sure that stuff was secure. So, yeah.
I think a lot of the effort there is trying to explain why half these questions don't matter. They're like, what? Why?
Yes.
Do you know what you're doing? Do you know what you're building? They're like, yeah, we do. It's just we need to explain it.
Well, the other thing I was going to say is I think the last PCI audit I did was 2018, and there were no questions about the cloud on there. And it was who has access to your data center? I'm like, I have no idea. The snowball truck, maybe. I'm not sure, but it's not me or anybody that I know. And I think that's one thing that AWS has actually done really well is gotten the compliance, the PCI, and all that other stuff for their different services, and that's easier now to pass through. As long as you're following the practices you need to follow, then their services underlying what you're building already are compliant with those things. So still sort of a pain, but I did a security audit not too long ago, and it's still the questions, not even related to PCI. It was what? It's 1992, and you still are running a Sun Microsystems data center on site. It's crazy.
I will say one more thing on this topic. Security didn't go away, and it's not solved. It's just it's totally different beast now, and the things that you have to worry about are actually really weird. So we didn't set up WAF properly on Begin, and we got DDoSed, and we didn't notice because our stuff's serverless and it just scaled up. Right? It was great. And it was great until I noticed, and I was like, oh no, my wallet. And but we set up WAF and blocked Turkmenistan, and everything was fine. But it's different, right? Like I never had a, oh no, this thing is scaling up too much problem. I was like, I used to have the opposite problem. How do we keep this thing running? Now it's like, oh no, how do we shut it off? So there's just a new set of concerns that are completely different for security, but it is just it's a lot nicer. I hated patching servers. That was horrible.
Yeah, to touch on that, I worked on I was on this tech ops team towards the beginning of my career, where it was operations. I had been doing serverless, and I got kind of added into it, and it was interesting because I was like applying that to this, and then it was like, we have 300 black box EC2 servers, and we've got to like turn them down and so on. And it was right around, I think it was Spectre meltdown, like the meltdown hack that happened. And of course those weren't patching, but the AWS side for serverless, like it patched underneath. And so there was like this whole thing of like, I don't even remember what the automation tools we were using were, and I had to write stuff for, but it was just this huge process of, we need to like SSH into hundreds of servers, and then we have to like write down that we upgraded it properly and patched it properly, and that was just a whole mess, and it required so many people and so much like oversight and all that stuff. And the whole time you're like looking over the fence and you're like, oh, but it's already done over here though. Like, what are we doing? Yeah. So I do want to.
That Heartbleed day was a nice day to be a serverless developer. It was great. It was like, oh, 100%. Huge exploit, and I'm not affected. Nice.
Absolutely. We do have a question from the audience. What are y'all's thoughts on the AWS Step Functions Workflow Studio in the context of going serverless? So what do y'all think about the Workflow Studio for Step Functions? Is it good? Is it bad? You a fan, not a fan?
It's amazing.
Yeah, it's awesome.
Yeah, I'm a big fan. I think that's some science fiction stuff right there. Like, we are just scratching the surface of what this means. Actually, that's the future of IaC right there. Deterministic, completely static graphs of no imperative code executing forever and scaling forever in the background for me. I think that's a very early moment though, and we don't totally know or understand what's going to happen here, but it does not look like the future is runtime languages when you look at that stuff.
Yeah, I think that as the same as I said with IaC, the thing with Workflow Studio is that it makes step functions usable for a bigger audience. Before, people were using step functions, but not that much. With Workflow Studio, more people can say, oh yeah, it's easy to do, I'm building step functions. And you should build step functions for everything you do, because then you can add error handling, you can do repeats, you can do whatever you like, SDK calls to AWS. Just do it in step functions and don't write Lambda. So the best serverless is not Lambda, but it's not using Lambda, but using managed services. And if you build step functions, you can do a lot of cool things. And Workflow Studio helps to get this to more people.
Yeah, I think it's this weird, like, no code, like this direction of no code type thing, right? Where it's all visual and it creates everything under the hood for you. And they're not quite there yet. Like, it's still, you still have to do quite a bit. You still know quite a bit about the services you're integrating with. But I think that's the step that they're taking. And again, I think people are familiar with workflows. And this is something that, whether it's Airtable or any of these other services, have been building for years now, where you're very familiar with this idea of, I want to do this, I want to change it into that, I want to store it there, I want to send it over here, I need to do some processing on it. So again, not 100% no code yet. But I mean, this is the other direction where, again, like even what we're doing with Serverless Cloud, API.get, right? It's great to have that endpoint. But then suddenly, what is that endpoint doing? If that endpoint is just accessing, some data and has to spit that data back, there's no reason to run imperative code in order to do that. That step can be completely bypassed, right? So if you're not declaring that, if you're not specifying that declaratively in some sort of, in CloudFormation or something, or as part of the states language, then how do you take imperative code and maybe transform that into it or whatever? So there's a lot of questions still. I think we're a long way off from people writing everything as step functions, but it is an interesting next step, or at least can get things complicated or easier. I'm not really sure what it does, but it does complicate the conversation at least.
Yeah, I don't know if I would categorize it as a as a no-code tool. I think it's a code generator. So, and this affects feedback loops. So rather than trying to bring down your deploy time, what you can do instead is use a hybrid of the console and your code on in your VS Code editor or whatever. So you can create your step function workflow. You can deploy it in the console, and once you're happy with it, you can get the definition, which is still code, and copy paste it into your CloudFormation and then deploy it. So I think it's a really interesting alternative or a different angle on how to reduce the feedback loop. Is that it's still code, it's still you're deploying CloudFormation, the slow thing we're calling CloudFormation, and yet the feedback loop is fast because there's this hybrid of using the console as well. So it's been people love it. People love the Workflow Studio. So it'll be really interesting to see what happens in the future with it.
But I think that you're thinking of this in the IaC bubble, where people are using Workflow Studio to generate the states language, which they then copy into their CloudFormation template. Right from the Workflow Studio, you can just publish the step function,
right.
And so it doesn't require you to copy that and put it into and it saves it, right? So then you have that definition, which you can then open back up and edit in the Workflow Studio again. So I do think it's more. I think it's more no code than it is code generator, but we can agree to disagree. But I think that's where it's moving, and I certainly think that is something that, again, as AWS continues to move into verticals, it's going to be something that is just going to be part of what they do.
Yeah, I'm just waiting for step functions in Zapier to have a child.
I look at our code base, and I've got a lot of functions that write a row to Dynamo and publish an event to SNS or SQS. Like, I got a lot of functions that do that. And I look at those functions every day and I think, you should be a step function and get out of my code base. And I can imagine in the future one day there's going to be a compile step that just takes my code and pops out that final artifact, and it runs in the cloud for as long as Amazon's APIs are stable. And I think that's a lovely idea from a compounding interest standpoint. I don't want to be rewriting my code every 6 months to chase runtime updates because some new thing happened out there in the internet. I don't care. I want to write that code and have it run forever so I can write more new code. I want to be adding value, not spinning my tires. And I think that there's a light at the end of that tunnel, and it looks like the step function stuff is on that road for me anyways. But early days, definitely.
Awesome. Well, I know that we're like over an hour mark here. So maybe we can, if y'all have time, we can keep going to the bonus topic here. The bonus topic, drumbeat, it's serverless sustainability. So the overall context of that, is serverless sustainability? Is it a buzzword? Is it something else? Is it real? Is it tangible? Do you get it by default? Do you have to do something? Do you have to you have to pay someone off at AWS to get that? So first off, I want to hand it over to Emrah. Emrah, what are your thoughts on serverless sustainability?
So just to make it more straight, we are talking about the how serverless is actually helping the world about they being more sustainable in terms of energy consumption and so on, right?
Yeah, exactly. So I guess
these sometimes the terms are mixing up each other, and it's just I just wanted to be rambling about the right thing. So the when it comes to sustainability in terms of cloud consumption, actually there's already an impact of using cloud resources rather than just dedicated data centers, and the serverless takes it into the next level in terms of the utilizing your functions in the best way possible, and utilizing with the most suitable resources possible, and still you are deciding for your memory consumption and it actually impacts the CPU decision, but it's with this scale to zero thing, serverless is definitely in terms of compute makes a positive impact on sustainability. And you can also think this in terms of like the databases, event streams, and everything. So when you build a completely serverless architecture, you're actually helping yourself in terms of budget, and also you're also helping the planet in terms of keeping it like less energy consumption to create like a smaller carbon footprint maybe.
Yeah, really well said. And I do want to ask Brian the same question here. Sustainability, serverless, what are your thoughts?
I think they're similar to carbon credits in that it's a thing we made up, but it's probably a good idea. And so someone's still running servers. I know someone's going to say this in the chat, so I'll just beat them to it. But if my workload is only utilizing a portion of those servers and Amazon's taking care of the efficiency gains, then that is a net win overall, like Emrah says. And it's better for us as a society to have more efficient use of our resources. The sort of flip side of this coin, though, is that the more efficient we get at things, the more of it we do. And so it's called Jevons law or Jevons law. And the idea is as we use more compute, we will use more compute. And as we get better at compute, we will continue to use more and more compute. And this all will drive us down a road of like, can we be more efficient to help save the world? That helps. We're also going to have to get better at how we get energy out of the ground, or how that energy is produced. And again, I think this comes back as a part of the shared responsibility between us as the developers and our vendors. We should be choosing clouds that are trying to have greener data centers and have better sources of their energy, and holding the clouds to account on this one, because these are very large energy sucking machines. And I'm actually really pleased in the last year, this has been a big theme with Amazon. They have a sustainability pillar as a part of their operational excellence writing. And it's something I recommend everybody go check out. Serverless puts us on the path, but this is not just an individual choice thing. I think this is a big systemic thing that we have to hold our vendors to account on, and ask that they source that energy from good places, because it really doesn't matter how efficient we are if we're still burning coal.
Yeah, really, really interesting. On that note, let me hand it over to Thorsten. What are your thoughts on serverless sustainability?
Yes, so as already said, it's these two things. So one thing, definitely serverless can be more efficient. So when you're running your own data center, if you're lucky, you'll get 20% utilization of your servers. If you run on AWS in containers, in EC2, whatever, maybe you'll get 50%. And if you're running serverless, you can reach something like 70-80% overall. Your Lambda function itself will have 100%, but there is capacity provided by you, by AWS for you. So it's still a lot higher. So that's the sustainability thing where it really is a pro. You will be better because you need less power for these things. But on the other hand, as you said, if it's better and cheaper to do it, and we will use more, it's like with the cars. Cars still use the same amount of fuel, so it just gets stronger. So it's not that we drive with 1 liter. It's just we have now 500 horsepower. So that's the thing. What do we do with it? But in general, I think we can get machines to do something, and it's way better to do something than to do nothing. And that's what's happening in data centers. It's like having 10 to 20% of utilization, and that's nowhere near sustainable. So serverless can get us in a range where it makes sense to run these computers.
Awesome. Made me think as well that, if we went from, EC2 or virtual machines to containers to cloud functions to then, we were talking about earlier with, more static, like some JSON, some VTL, maybe, that takes it down even further. Although VTL is, I saw Brian shriek at that. So
I winced. Yes.
Yeah. which makes sense. I remember being in my apartment, and right after AppSync came out and VTL was a thing, and then just on the floor in my apartment being like, I was asked by my company at the time to basically build this thing with AppSync, and we want to use it as like a show off project. And I'm sitting there going like, how does this work? Like, there's no documentation. I had to write the VTL stuff, and yeah, the console's gone miles and miles. And of course we have Gary on the panel who has a lot of insight into AWS AppSync, of course. But I want to get Gary's opinion. What are your thoughts on serverless sustainability and all the topics that we've kind of been talking about right now?
I don't know if I have a whole lot to say. I think we need to address our appetite to do more. If we can do more, we always do more, and that's a human problem, not a technical problem. Yeah, I'm really interested to see more in this space. I'm learning lots about it, so I don't know if I have anything else really to say insightful about it.
Awesome. Okay, and Jeremy, to close us out.
Yeah, I mean, I think, a lot of things were said about the efficiency and the energy piece of it. I mean, it would be a wonderful world if we could get to 100% electric cars, and, all of the data center, electricity was being generated by solar or wind or geothermal or something that was sustainable. And I think there's, I think the benefit that you have now is that we're going to continue to run more servers. They're going to keep building more data centers. Like, it's going to keep growing and growing. I think the utilization of an individual server is important. And when you're holding up a server with a VM and you're dedicating a piece of that running server and say, this server has to run 24 hours a day and nobody can use it but me, there's some reasons to do that. But then if you can build in a way that you don't have to be maybe as selfish, not saying that people are selfish that run VMs, but you can run your code in a little section of a code. It's like spot instances, for example, right? Like using spot instances is a great way to use unused capacity or free capacity. So I think that's an important piece of it. And I think that, people should definitely be looking at it, developers, if they want to make more responsible decisions about the planet and sustainability in general, then looking at ways to reduce the number of VMs that you're running, or, just resources you're tying up that you're not utilizing is hugely important. The other thing about sustainability, though, with serverless is, and I know Emrah set us off this path of talking sort of about, green and energy and that sort of stuff, but just the idea of having or building sustainable applications as well, right? And that's one of the things as we move more towards building step functions as a way to define these actions. That's going to grow and stay. Like, we just want to write new code, right? Brian said it. I want to write new code. I don't want to go back and fix old code. And so if you can write applications that are going to grow and going to adapt because the underlying resources that they're being deployed on or the way that they're run becomes better over time. That's one of the greatest things about serverless. Like, my DynamoDB tables just keep getting better and better and better, right? My Lambda functions keep getting faster. I get more storage. I get more capabilities. I can deploy to them. I can deploy containers to them now if I want to. I can do all kinds of things. The underlying infrastructure just keeps getting better, and I don't have to really do much to change it. Again, when you do have new features, you sometimes have to flip a switch somewhere to take advantage of it. But in terms of performance and all those other things, I mean, think about the efficiencies with Firecracker and some of these other things that they did that you just didn't even have to think about. So there's a type of sustainability that I think that's there as well. Whereas if you're building on containers today, is Kubernetes going to be around in 5 years? I mean, I hope not, but we'll see what happens.
Awesome. All right. Well, I think
spicy end.
Yeah, right. That kind of comes to a close. I love it. I guess let's see if there's any questions from the audience real quick as we wrap up. It looks like we have one. So it's from Davo. He said, I see a challenge about how should we surface monitoring errors and performance opportunities. And I think this is an interesting one because, we have third-party solutions that are existing, that are out there, the Lamigos, Dashbirds, Thundra, shout out to Emrah on the panel. And even, serverless Inc. has stuff too. And so, and then we have the native tools. And of course, AWS has been improving those. And we get things like CloudWatch Insights and all these awesome features there. And they're continuing to expand on it. For serverless 2022, March 31st, I'm pretty sure we're all on the same day. Sometimes, people are in New Zealand or something, and it's already the April. But for everybody here, What are your thoughts? 2022, you're building a serverless application. You've got to set up monitoring, performance metrics, all these things. What are you using, and what advice would you have to somebody that's approaching that problem for their production system? And yeah, who wants to? Anybody want to take a shot at it?
Yeah, so I would say, because I get this question a lot by clients, don't build your own. There are so many tools out there. Don't build your own. Pick one. I don't care which one, but don't invest your time, especially if you don't have that much time because you're a startup or whatever, to build your own Elastic or OpenSearch or Grafana, or whatever cluster to do monitoring. Just buy it. It's out there. It has been solved. Focus on your tools, on your software, on your product. Don't invent the next monitoring solution.
That's good advice. I would also add to that, do the simplest thing that can work. If you're in AWS, I find their services are adequate for the first pass anyways. I usually set up an alarm to see if my cold starts are over 1 second. So I want everything to remain sub-second in the system. I haven't seen that alarm in a long time, by the way. And yeah, CloudWatch Insights is great. I use that all the time. And if you build single responsibility functions and you have error monitoring set up with CloudWatch, you'll know where your errors are as soon as they happen. If you want to get fancy, you can publish those to an SNS topic, which might, do an alley-oop over to your Slack channel. But I wouldn't go much further than that. With your own stuff, you definitely would want to go to a third party where they've got more comprehensive solutions. But I've been finding the AWS stuff fine for us lately.
Yeah, I actually agree that for most, like, AWS has a lot of good tools. They can get pricey depending on which, what you're using and some of that stuff. But any of the third party tools are great. So if that's, especially if you're running a lot, like once you get into running a lot of Lambda functions, then AWS doesn't do the best job, I think, organizing those and surfacing those errors. And then, of course, if you're running across multiple accounts, I know AWS now lets you, surface CloudWatch monitoring across multiple accounts, but it's not like what you're going to get with Honeycomb or, Lamigo or some of these other ones, right? So it's just, even Sentry or some of those things. There's so many good services out there, right? It's really hard to choose. So you really can't go wrong with whichever one you pick. I would also say that I think distributed tracing is a little bit overhyped. I think for the most part that if you don't get a system with distributed tracing, it's not the end of the day. Just a couple of span tables here and there are going to give you more than enough information. And then again, the other thing I would just say too is embrace like OpenTelemetry as a standard. I think most people are going to that now, and it's just a good thing to make sure that all of your metrics and all of your everything that you've got instrumented is using OpenTelemetry is a great way to do it. And of course, if you don't know what that is, just pick anybody who mentions it, and they'll record all the stuff in OpenTelemetry for you, and then you can then switch providers pretty easily after the fact as well.
Yeah, I was in this sector of the industry, for 4 years before joining serverless. And with Tundra, and I agree with most of the comments. So if you are running as single functions with a single responsibility, with they are doing something themselves, like AWS resources will be mostly fine. But if you run something like more complex, like more and more event driven, even sometimes functions that you need to trace something, then there needs to be kind of these third-party solutions like Tundra, like Lumigo, like anything that you can think of, and like the serverless also has a solution. So in such cases, you will need such things. You will need a solution that shows you the whole life cycle of a trace, and you will need to track this. But I don't come across with like such systems very often. So like you may ask that is it like required to build such a system at the first place? If it's not, you will not need a complicated tool as well.
Yeah, I think CloudWatch is pretty good. I would say the only bit of advice I would say is make sure that your metrics are understandable. Like, don't just have a wall of metrics that maybe make you feel good but don't really say a whole lot. Think about what you're metricing or you're observing, and make sure it's helpful when you get called at 3 o'clock in the morning or whatever.
Awesome. Okay, well, thank you so much to the panel for sticking with us to kind of go into some of these extra topics from the audience, and as well as the sustainability topic. I really appreciate it, and I'm sure the audience appreciates, y'all's opinion on, such juicy topics like how do we monitor once we hit production? We're in production, stuff's going wrong. What should we have thought about this before? It's tough. So on that note, Thorsten, Emrah, Brian, Jeremy, Gary, thank you so much for being on the serverless panel today about the future of IaC and ROI of Going Serverless. Thank you to the audience for showing up and asking questions as well as being engaged. Definitely look at the panel right now. You can see the Twitter handles for everybody on here. Gary doesn't have it, but if you search Gary Jennings on Twitter, and/or we'll probably post it on our social media as well at the Serverless Guru one. And on that note, we're going to come to a close. So thanks everybody again. Have a beautiful day, and see you on the next one.
Thanks everyone.
Thanks for having me.
Thanks everybody. Bye.